Okay, a couple other questions. Can our antennas reach, out to get, to be able to detect life on, other worlds out there in the universe? And the answer is yeah. In theory, they could. If there was something, if there was a space alien civilization, broadcasting the way we broadcast out in Alpha Centauri, we'd probably be able to pick it up. Okay. Keep in mind again that we're not using those antennas to send stuff out on purpose. We're listening for the kind of noise that we hear on Earth and the nonstop party that is Earth. We're listening for that from other aliens. I should mention Cocconi and Morrison, who first came up with this idea of using radio to detect alien civilizations. They even actually had the idea that the aliens would be deliberately beaming signals to us specifically because they would see the sun and they would think the sun looks like a good place that there might be life, and they would be sending signals to us to say, hey, we're here. But that generally most SETI is looking for just the party noise. And I already mentioned that electromagnetic waves travel indefinitely far. So we on Earth have been broadcasting signals for almost 100 years. We're coming up, the first powerful commercial radio stations were in the 1920s, so we're 90-something years. That's 90 light years out. There's a lot of stars within 90 light years of Earth that could potentially have picked us up. Someone said, why do radio telescopes look like satellite dishes? That's because that's how you make a sensitive radio receiver, is you build a reflector that will reflect the signal that comes onto the dish down onto one little receiver. So it makes your receiver much more sensitive. The satellite dishes are using the technology developed for radio telescopes, not vice versa. Radio telescopes were doing this long before people had DirecTV dishes. DirecTV is like a little mini version of the things that Frank Drake was using, 60 years ago, back in the 1960. Another good question was, why do we think we could even communicate with any extraterrestrials who we might detect through SETI? How would we even know that their signals are signals from an intelligent civilization? Someone said, isn't this a violation of what Nicholas of Cusa said that we learned about back in the first chapter on aliens? Where Cusa said, how would you ever communicate with a being from another world? Cusa said, we can't even communicate with dogs, and we have a lot in common with dogs. You got your dog, you and your dog, you both drink water, you both breathe air, you have 2 ears to hear, 2 eyes to see, a nose, a mouth, a voice. You and your dog have a lot in common, and yet your ability to communicate with your dog is very, very limited. Okay, your dog and you cannot talk about Shakespeare. You can't talk about, America's Got Talent. There's a very limited amount of stuff. You can't teach your dog to, play baseball. There's a very limited amount of stuff that you can do with a dog. And so Nicholas Acusa is like, when you and your dog have so many things in common that you have as a point of communication, and you can't communicate, then how could you ever communicate with a being who's from a different world? Well, there's an answer to that question, and the answer is mathematics. As best we can tell, mathematics is the universal language that all human beings from may have different languages and different cultures and lots of different things, but everybody knows that this is 2 pins. Okay, this is 1 pin, this is 2 pins. And if you take 1 and 1, you get 2. So math, it transcends culture. And so the idea is that you could use mathematics as a basis of communication. And in fact, that most communication technologies are going to involve mathematics in certain ways so that you could be able to figure out at the very least, that you might not know exactly what they were saying, but you could tell it was an artificial signal. All right, by looking for mathematical patterns. So math is thought to be the key that would allow you to establish communication with an extraterrestrial race, and that would let you maybe even be able to figure out how to talk to them. So you would establish that they're there, and then maybe even be able to figure out how to talk with them. Someone asked, what if we're the most advanced civilization in the universe? And that's a nice question. That will be for the next next chapter that's going to come up. All right. I think so. A lot of good questions. I've been able to. Yeah, there's a lot. Oh, whoops. A couple more questions. Let's see. No, we got that. That was about who never proved Santa's not real. Who funds SETI. Oh, and the other thing. Can we change the limits of that technology have with technology? And the answer is no. Okay, technology is not magic. Either we will make a new scientific discovery and figure out how to another way to send signals besides the electromagnetic radiation that we use, or we're stuck with what we've got. Okay, you can't make the stuff we use to send signals travel faster than it naturally travels. All of our communication technology is basically based on 19th century discoveries, okay? Very early, about 220 years ago, a guy named Alessandro Volta was experimenting with electricity, and he decided to dissect a fish, an electric eel that produces electricity, it shock you. And he cut apart those fish, he dissected them, and he looked at the organs that the fish had that generated this electricity. And from that, when he looked at the fish, he decided he could reproduce that himself, and that's where the idea of a battery came from. And once you had an electric battery, you used battery and wires, you could transmit signals over wires, and it was almost in no time at all from the development of the battery to the development of transmission over wires with the telegraph. And that is wired technology, okay? So that's your cable, your internet cable, your cable TV cable that's bringing your signals in. And then in the late 19th century, it was discovered that you could produce electromagnetic waves artificially. It's actually, you don't really, it is also possible to send signals through light directly, just like you've seen like in movies or like flashing signals with a mirror or something. That's wireless. So in a sense, that's older. But insofar as really using it, developing radio, that was at the later 19th century. And a lot of the technology and stuff that we have is developed then. Now, if you looked, you could take a person in the 19th century and show them a cell phone, and they would be able to recognize almost everything that's in it. They'd say, wow, how did you make all this stuff so small? Because when they had it, it's all large and uses a lot of metal and needs a lot of power and stuff like that. But it will do, so the equivalent of a cell phone would take a building full of material. But they could do it, okay? It might be slower, but they could have the basic stuff. The thing they'd really be baffled about is the plastic. Okay, plastic is a 20th century technology, and so 19th century people wouldn't really know what the heck. What's this thing? This thing's made out of. I can understand. They'd understand everything it does, but they wouldn't understand like what's the case. Okay, that would really blow their minds. You can't change that. You can't make the technology more than it actually is. So that's very important because if aliens can't travel fast and they can't get here, then the people who are that raises a lot of difficulties about questions like Area 51 and abductions and things of that nature. We're trying to remember to put all this together to tack on the video about the Concorde, because I think that it's an excellent discussion of the whole technology issue. And I'll call it quits.